All right, so it's going to be relatively brief, 15 minutes. I'm going to share my stage with my colleague, Matt Raza-Barnett. So let me begin. So DDN is present in majority of the data centers around the world. I hope most of you are our customers either today or you will begin soon. So please come talk to us. EXAScaler platform, for those who are not familiar with this, it's the hardware and software complex. We provide the resilient turnkey appliance solution. At the bottom, we have the SFA appliance, which is the hardware layer featuring the either NVMe or over Fabric or SS solution SAS. A layer above is the EXAScaler management framework, or EMF for short. And then on top of that is the EXAScaler cluster solution. Basically, core 3 layers of our appliance platform. As of yesterday, we're shipping our latest and greatest AI 400X3 platform, which is the featuring the Bluefield enabled NVIDIA cards. It has the over 140 gigabytes per second in AI appliance acceleration, Docker enabled, and all of the other new features and cool bells and whistles. So as I said, come talk to us about it. I've also shipping our previous solutions in parallel with that. All right. So bulk of my talk will be around the EMF. I'm responsible for developing this piece of software. So what is EMF? Essentially, this is the distributed management framework, which is the core of the orchestrator layer in our solution. It's responsible for the end-to-end cluster deployment. It's developed to be scalable and fault-tolerant. We're supporting quite large, for DDN, quite large deployments around the globe with some of our key customers. It's really easy to integrate. It's featuring the secure support for the encryption, the authentication, authorization, role-based access control. It supports the online upgrades. It does one of the key features of the EMF framework is observability. We pay a lot of attention to that. Observability is one of the buzzwords around the globe these days. How do I know when something is happening with my system? So we pay a lot of attention to login, monitoring, scalable diagnostic collections. It's all based on the Prometheus exporters and GraphQL API support right now. In nutshell, this is the architecture. Essentially, we have the EMF manager, which is the distributed. There is a central one and basically a shadow EMF manager running on the system. A bunch of EMF agents associated with each VM, so it's somewhat semi-distributed system. It's very scalable and hub and spoke model. We're featuring using the service mesh today with the TLS and secure communications. One of the core items are the online upgrades. Basically, the goal was to reduce the complexity, basically run the system in production while we're upgrading it. We have ability to upgrade all components at once, or you can pick and choose which components you want to upgrade. Basically, from the operator's perspective, ensure that it's a single procedure for everything, all the firmware, all the software, all the components from hardware layer all the way to the luster. And as I mentioned, eliminate the system shutdown. So stay online from the customer perspective. So that's one of the goals. Observability. Keyword, buzzword. We're trying to do the near real-time health monitoring for all important aspects of the system. Basically, if you don't monitor your system, all the problems have a tendency to snowball into large problems. It can give impression of the software instability, and definitely it will impact performance one way or another. Issues are generally a function of several factors, hardware, software, whatever. And as the system scales, the problems also scale with the system. There are a couple components that exist in EMF observability world today. On one hand, the continuous monitoring solution based on EMF health. That's basically based on the real-time metrics. We essentially, the key question is what's going on with my system? Is my system down? You can get the alerts through a variety of channels. Slack, Teams, email, webhook, Grafana are supported today, but additional channels, PagerDuty, whatnot, can be added basically within a day or 2 days. It's really easy to develop. On the other hand, there is a tool called EMF Analyze, which features the point-in-time diagnostic tool where the sysadmin or the operator can run and collect all the checks, configurations from network performance in depth and get a comprehensive report about what is going on with the system. Is my system stable? In fact, we're running this tool right before any upgrades, so we can get a comprehensive report whether the upgrade can be finalized without any issues, or is there something we need to address? So kind of twofold thing. And then challenges we're facing. So kind of administrator challenges. So pushing the boundaries of management deployment at the large scale. As the system grows, as I mentioned earlier, we're growing beyond the hundreds of appliances these days. Collating these metrics, getting lots of tons of information. We're facing the challenge of storing this data, processing this data in a near real time. So alert fatigue is a very real thing with the administrator. How do I get the right data from the barrage of logs, barrage of metrics, barrage of whatever information is coming my way? So that's one of the things we're trying to address. And then how do I act on it? One of the things we're trying to address with the observability is extract the right information and deliver it to the administrator at the right time, so the administrator can make an intelligent, informed decision based on the information they're getting. So, and remember, trying to do this at the near real time. With that, I'll pass the stage to my colleague, Matt.
Thanks, Ivan. Yeah, I was just going to use the last 5 minutes just to talk about some of the additional enhancements that we provide within EXAScaler, some of the extra features that we provide on top of the foundations of Lustre. So I've highlighted 3 of these here. On the left, client-side data compression is one of the most recent. You may well have seen some talks about this at previous Lug events. This is essentially providing users the ability to set up client-side compression at a file or directory level with great scalability that leverages the client CPU to do the compression. We also have another feature, hot nodes. This is a productization of the persistent client cache feature within Lustre. This is a way in which that we can leverage the local NVMe devices that is frequently found on many of the client nodes that we're running at in large AI data centers nowadays. DGX nodes will often have substantial amounts of local NVMe, and we can leverage that to cache data on the client. We provide an additional caching daemon to help the administration of that, and this has been shown at a number of our largest customers to really improve overall efficiency for their workloads that frequently reread data. And lastly, hot pools. This is another feature that we've had for a while now in EXAScaler. This is a way in which we build on top of the file level redundancy feature within Lustre, and we're able to then use that to transparently tier data between two different pools within the file system. So if you have a smaller fast flash tier and a much larger, colder hard disk drive or QLC flash pool, this feature can take away the effort of maintaining that tiering for you. So we have policy engines that are running and that they take care of the promotion or the demotion of data between the two pools. Another feature, one we don't often talk about very much, but just as equally useful for the administrator nowadays, this is a feature we call fast search. So essentially, this is a completely different approach to being able to run kind of queries or do kind of policy queries on a file system. Often, many other approaches, such as like Robin Hood that we heard about earlier, or others, they will try to query that from the front-end side, from the client, either scanning the file system, either in parallel or by consuming changelogs. With this feature, we're taking like a different approach, where we actually scan the metadata targets themselves directly. We read all of the inodes on the device. And it turns out, you can really do that at a very high speed. So we can scan 1 billion files here in around 10 minutes. You can easily do way more than 1 million inodes a second of scanning. And this scales very well as you add more metadata targets into the file system. And what this means is that we can actually run a policy query or a search on the file system within minutes, even on a very large scale. And this is a feature we've just continually expanded over the years. We've added in automatic queries or useful policy reports for the administrator, such as the top largest files or directories within the file system, or produce histograms of the size ratio of files throughout the file system, or even the compression ratio. And we even use this in certain administrative tasks, such as if you want to perhaps migrate data off of a very full OST, you can use this scan to quickly, within seconds, list all of the contents of that OST and then feed that into your migration task. And we build on this into our reporting. So here's some screenshots from our DDN Insight monitoring tool. So this can now leverage running one of these fast scan queries on like a daily basis and produce file system level histograms of file size distribution, file age distribution, or even on the top right doing a per directory consumption graph that you can click down through and see how much data are in the top N directories and so on. So this is quite a powerful capability, something we're always looking to expand and produce more useful reports for the administrator from. And just for last thing, I'll just point out some of the additional enhancements that we're continuing to work on throughout 2025 and beyond. So there's multiple new features under development within EXAScaler. One of particular focus at the moment is working on expanding our multi-tenancy capabilities, making that a much more easy to use, more administrator-friendly capability by introducing abstractions into our management layer, providing CLI API commands to take some of the complexity away for that, as well as expanding the fundamental tools within the file system, node map, and so on. We're also working on a feature to have a kind of trash can or undelete capability so that we can help users if they accidentally delete or there's malicious deletion of data within the file system. We're interested in caching from object storage, so you may well have heard we're also now providing a large-scale object storage and other appliance solution. So we're looking at integrations working with that. Fault tolerance within the MGS, always something we're keen to improve within the file system so that we can have much more resiliency and redundancy of these core services. And lastly, expanding on our capabilities in the file system with token bucket filter. Again, being able to productize that, make these features something that are really easy to use and work at the largest scales in which we operate. So I think that is all of the time. I will say thank you. Okay.
Maybe
Do we have any questions for our DDN presenters? I know I personally would like to get almost a photograph of slide number 14.
Which one was that? 14. This one?
Sorry, thanks. Just a quick question, if you can go to the next slide, please. This is a really cool feature that allows us to see the breakdown directory usage. I just wonder, is this achieved by some sort of a policy engine?
No, this is built on the same this fast search feature. So essentially, it will be a point-in-time snapshot of that directory consumption data. But by being able to run that very quickly, then we're essentially trying to answer the question when it's asked, right? So instead of continually trying to keep the database of the namespace up to date so that we can then query it, we're instead just querying that directly from the file system metadata itself. So when you ask, what is my file size distribution, we then try to answer that within minutes. But that is often at the largest scales, that's quite comparable to the sort of time that you might take to pull that out of a database, for example. So,
Got it. Is that a snapshot of the file system?
it's not from a snapshot, no. So it will be at the time that it's scanned. So obviously there might be some small changes that are happening while that's done. But again, if we're able to perform that scan within minutes, then it's going to still be very accurate, really, at the time it was asked. Okay.
Hey, what's the interface to your fast scan?
It's a CLI tool. It's actually, you can sort of see an example of me like calling a query to run the report up here. You do have to run it against all of the metadata targets in this case, and then you converge that back, and then you get out a report at the end that can be in various formats, JSON, YAML, CSV. And then on this next slide, the visualizations are things that we're building to like pass that JSON output and then present the visualization.
So in other words, you could just dump the entire file system contents to a CSV, for instance?
I mean, essentially, yeah.
Oh, that's cool.
Yep.
Thank you.
Very quick one. What version of Lustre are you using to develop those additional features, and why is it not the LTS?
So I think these are developed, so this is in our EXAScaler 6 file system that's based on 2.14 as the base, but obviously has significant amount of development that's happened on top of that. Why is it not in the LTS? I think a number of these do eventually make their way back up, but initially they're worked on first for these customers, and then we gradually upstream those over time.
Isn't that duplicating development effort somehow between the community edition and this branch?
Yeah. So I just said, I don't see that it's unclear. If you're a DDN customer, when you're using Marlowe, that's the LTS equivalent. And when you're using the other systems, you have 2.15 LTS, community versions. So I think it's just, it's very clear. It's the same if you were working with other vendors, you'd have something else as well, right? So yeah, and these things, this specific thing is not something that is Lustre kernel, so that's, orthogonal to that development, but like the other features get developed by our people, our engineers, and they, appear in upstream community releases, and they may appear in EXAScaler releases as well, but it's not necessarily tightly coupled.
Thank you. Thanks.
Okay, thanks.